that is exactly the twice of the angle at the AXB. Okay, so this is the proof. You can also use this method, and you can also use the my method which I have used. Okay, the both are simple. Thus the angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at the circumference of the circle. Two further theorems can be deduced immediately from this first one. You can quote the previous theorems to justify these proofs. So this is the next theorem, and you can see that next theorem is that angles subtended by an arc in the same segment of the circle are equal. Okay, so now the next theorem is angles subtended by an arc in the same segment of a circle are equal. So this is the arc AB, and here the angle ARB, this is also x, AQB, this is also x, APB, this is also x. These three angles are equal. Why? Join AO and OB, right? So here you can see that this will becomes AOB, that is 2x, right? If the angle at P is x, so it will becomes angle at the center of the circle is 2x. Again, the angle at Q will be x, so the angle at center is 2x. The angle at R is x, because all angles are generated by a single arc or by a single chord. It means that the all angles are same, right? So this is a small theorem by using the previous results. Okay, another theorem is that the angle subtended in a semicircle is a right angle. How? So the proof is that if the line is a diameter, because this is a semicircle, so the line must be a diameter because it passes through the center of the circle. Since AB is a diameter, so AOB, this angle is 180 degrees, right? Or this angle is also 180 degrees. So now you can see that the angle at the center of the circle by the arc AB is equals to 180 degrees. So the angle subtended by the same arc at circumference of the circle is exactly the half. And what is the half of 180? That is 90 degrees. That's so simple. So that's why these two theorems use the previous results. Okay, so the previous result is very important. Since AB is a diameter, AOB is a straight line, thus angle AOB is 180 degrees. Using the result that the angle at the circumference is half that at the center, so the angle APB is equals to 180 degrees divided by 2, that is 90 degrees. Okay, then the angle will be a right angle. So the next example is that find the value of the angle marked x and y. And how we can find the x and y? We just meet these 2 points, right? We just meet these 2 points, and you can see that the 42 angle, this angle is 42, and that is generated by, let's suppose this is AB, a chord, and also this angle is in the same segment, so this will also be 44. Okay, angle x is equals to 44. Why? Because angle in the same segment are equal, and they are generated by a single chord or a single segment or a single arc, right? So this is 44. Now you can see that this is a triangle, and all angles are added in a triangle up to 180. So it means that 44 plus 70 plus y. 44 plus 70 plus y is equals to 180. So 114 is plus y is equals to 180. So y is equals to 180 minus 114. Y is equals to 66. So this is your answer. Understand? You can get the answer by of x and y by this method, right? Next is the next example, that is so simple. Find the values of the angle marked as x and y. So what is x? X is exactly the half. Why? Because if we just draw a line, so you can see that this is the angle at the center and this is angle at the circumference, so that is half, so it is 35. That's so simple. So you can also say that this is a semicircle and the semicircle, the angle at the circumference is 90 degrees. So if this 90, this 62, this will be 28 by using the method that the angle sum in a triangle is 180. Okay, that's so simple. So here is the next exercise, exercise 17.2. You have to do some questions from this exercise. Question number 3, 5, 9, 11, 15. Okay, do all these questions quickly, then we will start the next. Any problem in previous work? If you have any problem in the exercise, then you can tell me. I'll solve the exercise questions also. Okay, next one is further circle theorems. So the next theorem is that the angle subtended in the opposite segments. We are dealing in previous theorem in just a single segment. In a same segment, the all angles are same. All angles are same. But in the opposite segment, the angles are added up to 180. It means that this is another theorem. The angles subtended in opposite segments add up to 180. So this angle and this angle are added up to 180. This angle and this angle are added up to 180. How? Denote the angle APB and AQB as respectively P and Q. So this is P, this will be 2P, this is Q, so this will be 2Q. As in previous theorem, that angle at the center is twice the angle at the circumference. Also, if we rotate the circle or we use the different opposite arc, so angle at the circumference is half of the angle at the center, right? This is the phenomena used in this figure. Then the angle at the center are twice these, that is 2P and 2Q that we have discussed. So the angle at point O added up to 360. So it means that 2P plus 2Q is equals to 360. So 2 of P plus Q is equals to 360 and P plus Q are added up to 180. What is P? That is this one. What is Q? That is this one. So they are opposite angles, so that are added and your answer will be 180. This is the proof of this theorem, right? The point APPQ form a quadrilateral whose vertices lie on a circle. It is known as a cyclic quadrilateral also. Thus the theorem may also be stated as opposite angles of a cyclic quadrilateral add up to 180. So it means that theorem statement must be this one. This can also be changed as this one, right? So the wording does not change the meaning of the theorem. So you have to conscious about the wording of the statement. Okay, next is the example. So that's so simple. X plus 116 is equals to 180. So what is the value of x? That is 64. That is so simple. Again, this is 96. So if we just make another two lines, so what is that answer? That answer will be 84, because the sum of these two angles are 180. So if this is 84, this is double of 84, that is 168, right? So here we use two theorems at the same time. Do you have any problem in this example? If you have any problem, you can ask me anytime. I am available.